This is how a website looks for a computer. No wonder computers are able to read but cannot understand the information which websites contain. The semantic web could make websites understandable for both the human user and the machine. The research of the Digital Enterprise Research Institute focuses on adding semantics to computer languages, thus enabling machines to understand the meaning of data. DERI Innsbruck was founded in 2002 by Professor Dr. Dieter Fensel at the University of Innsbruck in Austria. More than 60 researchers of many different nationalities work at DERI Innsbruck. DERI Innsbruck is integrated in an international network of other DERI institutes in Asia, Europe and the USA. DERI is currently involved in more than 20 both nationally funded and EU-funded research projects, as well as international standardization consortiums such as W3C and OASIS. A business development team takes care of the interaction with DERI's industrial counterparts, which is crucial for the validation and dissemination of research results. At DERI Innsbruck, researchers are organized into 4 distinct clusters. Each cluster has a discrete research focus.
So the Reasonable Semantic Web Services cluster aims to define formal languages for describing services and service-oriented architectures.
The SEBIS cluster works on applications of semantic web technology. That is, we are trying to make ontologies and semantic web services applicable in real-world scenarios such as e-tourism, e-business and e-government.
We, in our research cluster UbiServe, deal with ubiquitous computing as an environment for semantic web service technology.
C-cluster works on the system of the 21st century to enable automatic discovery, mediation, interoperation and invocation of web services.
Semantic web services, semantically enabled service-oriented architecture, so each is a step towards increased complexity but also potential impact.
One way to approach the enrichment of semantics of computer languages is with the utilization of ontologies. Ontologies are data models that provide both a structural and a semantic description about a particular domain. With well-defined ontologies, a machine is able to pick out only those documents that contain pertinent information. While the original web consisted of data that was only published persistently, it is in some contexts more appropriate to solely expose functionality in the form of services. This has created the idea of web services. However, in an open environment of the scale of the web, finding the proper service and combining multiple services so that they fulfill a given goal is incredibly complex. Semantic web services is the idea to describe services available on the web in a machine-understandable way, so that computers are able to find and combine such services autonomously. A semantically enabled service-oriented architecture is essentially a collection of semantic web services. These services communicate with each other. Service-oriented computing is rapidly becoming the dominant computing paradigm.
Basically 30 years ago we managed to move from hardware to software, and we are now in a similar process where we move from software to serviceware.
DERI research covers a wide range of topics.
Modeling non-functional properties of a service.
Reasoner for the semantic execution environment. Choreography interfaces.
Automated semantic annotation and ontology construction.
Integration of different knowledge representation formalism, implicit knowledge, explicit.
New techniques in description logic reasoning.
Semantic web service negotiation.
With reasoning about formal represented knowledge.
Triple space computing for semantic web services.
For instance, ubiquitous service discovery.
Semantic web service discovery for the web service execution environment.
New communication mediums for service-to-service communication tailored to the needs of machines.
Architecture for the semantic web services system.
DERI's researchers are also very active in teaching. The courses convey solid knowledge in computer science with a focus on intelligent information systems. visionary technologies for the next generation of the web and applications of semantic web technologies. Conflicts between computer languages, applications and systems have always hampered interoperability and communication. With semantically enabled technologies, computers will be able to communicate more intelligently. This will allow humans to concentrate on intellectual work.
To apply semantic web technology to typical e-business scenarios, such as business process management, e-procurement, or the maintenance of enterprise resource planning systems.
End users will be able to search the web much more conveniently for suitable offerings. Semantically enabled service-oriented architectures will support us in nearly all aspects of our daily life, making access to information as pervasive as access to electricity is today. Imagine a world of efficiency where, although we all speak different languages, we are able to understand one another and no question goes unanswered.